Hello and welcome to the latest edition of the IRS Rail webinars. This is part 2 of the two-part webinar series on what can AI do to streamline railway maintenance processes, produced by the International Railway Summit in association with Partium. I'm Jules Omura, the Managing Director of IRIS Events, and it's my pleasure to welcome you all to this session. So at the last count, we had over 270 people from 54 countries registered for today, which is a great number. So welcome to those of you attending our webinar program for the first time, and welcome back if you've joined us before. We couldn't have reached this number without the help of UEFA, so special thanks to them for not scheduling a match at this time. Sit back, relax, and enjoy the webinar, which promises to be the most informative and interactive 90 minutes of the day. I'm delighted to have the support of sector leaders as speakers with us today. In particular, we are fortunate to have the support of our sponsor, Partium, which allows us to provide this important debate for anyone to watch for free. Partium is a leading global expert in enterprise parts search. Rail operators, including Deutsche Bahn and ÖBB, rely on Partium's AI-powered parts search engine to identify and locate components that need to be replaced, improving efficiency, safety and reliability. So I look forward to learning about Partium's take on the use of AI in train maintenance from their CEO, Filip Deskovic. I'm equally grateful to Philippe Delard from SNCF Voyageur and Nenad Mijatovic from Alstom for sharing their expertise with us today. This is an interactive session. The audience are invited to participate proactively in the discussion. On your screen, you will see a chat section. You're welcome to chat with other audience members and comment on the debate. Next to the chat tab, you will find Q&A, where you can post your questions to the speakers and also vote for the questions that you like to ask the speakers during the panel discussion. So do make use of this feature. We have 4 audience polls today. These will be asked before or during the speaker's presentation. And this will be a chance to voice your opinion on specific questions. All of the speaker presentations are available today to download from the handouts section of your screen. Last but not least, at the end of the session, you will receive an evaluation form by email. It's very important for us to get your feedback so we can continue to provide webinars that meet your expectations. We're on LinkedIn and X. You can follow us at Rail Summit, and please use hashtag IRS Rail Webinars. If you enjoy the session, do continue the debate on these platforms. Now it's my pleasure to introduce you to our moderator for today, Paolo Guglielminetti, partner at PwC Italy, and PwC's Global Railways and Rules leader. If you joined our webinar or attended the International Railway Summit before, the chances are you have already met Paolo. His extensive knowledge on mobility and digital makes him one of our favorite moderators to work with. So let's get started on building a super AI for train maintenance. Should operators collaborate on the next generation of systems? And handing the ball over to the Italian referee for the kickoff. Paolo, over to you.
Thanks, Jules, and thank you, IRS, to involve me another time on a super interesting discussion. The exceptional attendance we have today demonstrates the interest of the topic Partium has suggested. Thanks to Partium for bringing us to the table for such discussion. Railways historically are, let's say, quite segregated for technical reason and also geopolitical reason. They tend to share data only when this is imposed by regulation. However, there are several areas where building collective, let's say, knowledge will generate benefits for all the parties. And developing a better AI is one of those areas. As currently said in the introduction of this webinar, the more we know, the more we share, the better will be the development of algorithm for predictive maintenance. And beside of that, operators will learn and OEMs will learn from each other's experience, and this will also improve the overall efficiency of technology in this area. So in this live webinar, we will involve all parties of the industry. From rail operator side, we have Philippe Delard, we have Filip Deskovic from the technological provider, and Nenad Mijatovic from Alstom, from the OEM. So we have all the parties, all the industry that are key in developing such collaborative effort. So thanks again. I suggest everybody also to think about their question, because we will have a very interactive and hopefully fruitful panel discussion after the presentation. And it is now the time for our first presentation. I will then introduce more extensively Philippe de la Harpe. Philippe is responsible of RD projects for remote diagnostic and artificial intelligence in SNCF Voyageurs, so the passenger operator of the SNCF group. He's in charge of promoting innovation, in particular in maintenance operation for SNCF Voyageurs, and working on AI application in those areas. He's specialized several years in maintenance, so he knows the technological but also the process side of the topic. Philippe, the floor is yours.
Thank you, Paolo. Hi, everybody. So AI for train maintenance, maybe not yet the super AI and not the ChatGPT train, oh my, but something yet. It's all begins with data. So with data at the SNCF Group, we have been doing remote diagnosis, and it's already changed the game, changed the way we view maintenance, and allowed us to develop proactive troubleshooting and predictive maintenance for about 10 years already. And with this data, we've been able to replace systematic inspection tasks by remote inspection tasks with the help of sensors and data transmission. And that was the first step with data. But we also put some intelligence in the data, and this enabled us to go further and interpret what was going to happen and avoid failures to come, thus enabling a better reliability of our fleets. So we've been applying all these capabilities to our more recent fleets, which are very talkative, and it's much information bits to the ground for every operation. Doors closing and opening at every station provide us a wide range of sensor data and enable us to decide whether it's just a foot blocking the door at one station or it is really a hard point on the door, and so on. But all this, in the end, relies on the expertise of engineers and technicians who know how the car, how the locomotive, how the EMU is built, how it works, and with the experience from troubleshooting, enables them to identify the very signature that is the clear prediction of a failure to come. And so, naturally, when we get more and more data for more and more recent fleet, or when we fit all the fleet with sensors when overhauling, IoT or more traditional ones, we have the idea to go for more, and well, why not do machine learning? And well, clearly machine learning would be the very thing. Predictive maintenance, that's the no-brainer thing, as it seems, but in fact it's just very difficult. Why? Because in fact the big data, the big parts of our data is low quality data. On the left, you see there the typical figures for one EMU, okay? And we have very frequent informations coming from the train, so it's the most recent ones. They say everything happening. Oh, sorry. everything happening to them, from opening and closing a door, opening and closing a switch, everything. And so we have about 10,000 operational defects, something that's wrong, but that has no impact. Thousands detecting anomalies, something with an impact, and 5 to 10 equipment failures with an impact on the commercial mission, and 2 to 5 in-service failures, which cause the mission to be degraded or aborted. Okay, and that's for 1 year. It seems a lot of information, but in fact, if you see on the right, only in-service failures have an extensive labeling in the sense of machine learning. This is, management says it never should happen again, and so we conduct all the root cause analysis, all the investigation to find how to make it never happen again, and to replace the part, to change maintenance, and so on. So this upper part of the iceberg of data is very, very well documented. Just on the one, equipment failures are still quite well documented because there are parts replacement, there's work that has been done, and so at least for billing, there is something in the books, in the maintenance books. So we have something, we have quite reliable data about equipment failures. But when it comes to detected anomalies, well, they are helpful for maintenance, but if the testability has been correctly assessed with the OEM during warranty, that's fine. Well, not too bad. And with raw data, who cares? So we get more and more data, but useful data, the really useful data, the most correctly labeled data, is the rarest and the most expensive. Okay, data, quality data comes to a cost. And when trying to do predictive maintenance just with supervised machine learning, we learned that at a cost. We started as early as 2015 with trying to learn from those in-service failures. So we had a set of more than 400 incidents, in-service failures, with all kind of function being in the data set. And we tried to learn. But as we had very, very few failures, that was the nice thing the data scientists told us. You have too few failures. Okay, so we couldn't learn efficiently, and we couldn't achieve a quality prediction, something useful for maintenance. And 2019, we also tried on TGVs, this time with more data. We tried with more than 20,000 repairs on traction units. But repairs were not sufficiently specific targets, because repairs are not anomalies, especially on complex functions. You have to do more than one time intervention. So it's difficult to learn from it, and still we couldn't achieve. We achieved something. We detected high-risk trains, but not sufficiently high-risk train to have a proper economic balance and trigger a maintenance task on those trains. We would have to do 5 times a task to find one sick train, so it wasn't enough. And even when we tried again during the last 3 years with something very, very advanced, with Markov hidden states and so on, and more than 100,000 repairs analyzed with all context, we achieved something that should be efficient. So the theory is assessed, but still not operational. So My message here is, supervised learning was not an easy thing, and we're still looking for sufficient and sufficiently labeled data. So was it the end? No. Naturally, we're still going for predictive maintenance, and what we have turned to was unsupervised learning with data clustering. So with two assumptions. The first one was that we were doing our job correctly. That was that the biggest cluster was the data of healthy doors. This one is on doors. And the second assumption being that there's a regularity, and the faults to come would be in the groups of behavior that are already observed on the fleet. And this enables us to find groups of behavior clusters that we are able to label with the help of the repairs and the inspections in the workshops. So it's not just the experts and not just the data, it's all the organization working properly to label, not this time every bit of data, but sufficient part of it to identify each cluster and enable each new point in the clusters to be identified, and so trigger intervention when it happens. So that's how we tackled part of the problem. But it's still a heavy task because it needs a huge quantity of data, and we do not have it on every train or every equipment. So next, what do we imagine? We imagine that AI will be most needed at every step of the maintenance cycle, because when we go for predictive maintenance, we take from systematic maintenance big maintenance lumps, and we break them into small pieces, so it's more difficult for planning. You have to trigger opportunistic maintenance and insert it at the right time in the planning. You have to manage the staff, the competence, the workshop capacity, and the spare parts, of course. So it's bigger than what the human brain can manage in the short time we have for organizing maintenance. And there we really think there is something to do with AI, and we are going for it, even if we naturally cannot yet do everything with AI, because it's not only on small parameters that we have everything that we need. And next, what's to come, that's full AI for trains, because here you see TGVM with entering service next year. This one is 2 terabytes per month per train, where we have 2 terabytes per year for the entire TGV fleet. So we'll need the full power to tackle this mountain of data. Thank you.
Thanks a lot. Thanks a lot, Philippe. A lot of interesting insights from your experience as R&D for a big operator. Now we will have the first poll before introducing the second speaker. Jules.
Thank you very much, Paolo. So if we can launch a poll, please. Yeah, so the audience members, you have the ability to respond to this. Do you think that both OEMs and operators, i.e. OEMs customers, could benefit from a joint approach in building or providing data for train maintenance AI? So I work for an operator and I think yes, or I think no. I work for an OEM and I think yes or no. I work for a third party, e.g. consulting company, and I think yes or no. So if you work for an operator, OEM, or anyone else, please do respond. And I think yes, do respond. I think if you can still. Sorry, I think it's gone now. I think let's launch this again.
We have about 70 answers yet.
It seems to work though. It
My
seems to work.
screen isn't working. Okay, so if you haven't still responded, do please respond, and let's close in 5 seconds or so. If you can make your final choice, and yes, and let's close the poll. Thank you. So if everyone can go to poll section of your screen, and the closed, you will see the results. So
there is clear majority on all groups that says that
quite positive response here.
The benefit, let's say, are confirmed by our audience on all groups. We just few. We have almost 100 answers so far. So very large majority. Philip Deskovich. So you can build those on this. You are the CEO of Partium. You practically build the company, creating this actual presence before a long career in the technological sectors in several companies. So you are currently the CEO of Partium, our sponsor of today. You have the floor, and thank you again for organizing with the IRS this event.
Thank you for the intro, and thank you everybody for joining this. I'm really excited that we have literally excited that we have this kind of conversation. So we're the sponsor here, but don't worry, I won't do a marketing session out of this. I'm really personally interested in the topic in general and love this discussion. And it's one of those very, in my opinion, also very European topics that we should tackle. Just to give you a quick, I'll give you a quick overview of what we do at Partium. So we are a software company. So we're not an operator, we're not an OEM. We are a company that we started about 8 years ago to work on the problem of identifying parts, spare parts in complex technical environments, and we build a solution around that. And it's AI based. There's also other things, but AI plays a big role in this thing. And we, this is just to show you, we have customers in all geos and also all kinds of segments, but especially also in the railway segment. And the problem we solve, and this is maybe also important here. I loved Philippe Delorme's presentation about the predictive maintenance aspects, and just hearing that there's a new train type coming out with 2 terabytes per month and so on. That's impressive, and I'm looking forward to seeing results in terms of improvements there. But so I can only give you a very a different perspective on a different topic that we are totally focused on, and that's this part search area, and what a joint approach in this segment would open up. And so the problem we're solving, or that the challenge that our customers have usually, especially in the train area, is this, that it takes forever in their maintenance factories to search for part IDs usually, right? So that's the thing, that this comes with all the problems that you all, I'm sure, know. So there's also a changing workforce, and it's difficult to find the right people, and they come from all over the place by now, and that's good, but at the same time this brings new challenges and so on. And the data here, it says weak. I think the diplomatic way to say it is probably it's heterogeneous quality of the data, but it's basically not optimal. And there's also, with all the new train types coming and so on, there's a growing number of parts everywhere. So this problem is not going away; it's actually increasing. And what we have built super short here is a technology that basically on any kind of mobile device, it also works on desktops and so on. But basically, a technician can very quickly identify a part through all kinds of means, including taking pictures and all other things that you can imagine. And that basically solves that problem to a very large extent. What's interesting though is when you look at it, is that behind it is, of course, a capability to leverage the data that is available around the parts, and we work only today if we have a new customer, so they have a certain amount of data and about their parts, and it's in their SAP or whatever kind of systems they have, and that's used and that's that's the basis of our that we work with, and we built the whole tech around this problem that the data is not great and it still works very well and so on. What's interesting though is that when you look at all kinds of segments, so it's not limited to the railway sector, but it's of course especially true for the railway sector. You have those two main groups there. You have OEMs, or people who sell parts in general, but basically the companies who produce beautiful machines who are then used. And you have the operators of those machines in trains or all kinds of equipment, basically. And the data that is really helpful in order to solve our little problem, for example, of identifying parts, is actually available in all kinds of sources across both areas here, right? So both on the OEM side and the operator side. And it's similar, I think we'll hear more about that also on the predictive maintenance side, but for our side, it's really like this. And so what's interesting is to understand, first of all, that there is a lot of information out there that could be leveraged. And actually right now we're working with just the data of, let's say, Deutsche Bahn to solve the Deutsche Bahn problem. But actually that works, but is it really the best you can achieve in the industry and the segment? Probably no. And what's important to understand, and I think is that with the recent developments around AI technology, there are two major steps that were made, in my opinion, that really, as humans, and especially in the railway segment, should push us to rethink the whole approaches around cooperation and so on. And we, Paulo, I think, and also Philippe mentioned it in the past, it was always difficult to cooperate, and it still is, and so on. But there are two key things now that I think must make us rethink what we're doing. But the first one is, and many of you in the audience probably are familiar with AI technology, so I won't go into details and so on, but just, the first thing is that there was a significant step forward made in terms of what AI systems can in general do in terms of understanding concepts. So we came, 10 years ago or 8 years ago, so we were recognizing patterns. So with AI systems, so it was, you like a parrot here, you show it the yellow pentagon, and you give it a grape if it chooses that one, and if you show it the blue circle, you don't give it food. And then after a while, it understands I need to choose this, and you multiply this by 1 million parts or objects or whatever, and that's what you can do with an AI system. Today, we are with what is called semantic AI approaches. We are at a level where those things understand concepts. So, what does that mean in things like part search? It means I do not need to show my the AI system actually every part that I have, and I don't need to have perfect data around those parts. The AI system will basically know a lot of parts in general. So it will understand what a hydraulic valve is in a brake system, or it will understand components of an air conditioning system, even if it has never seen exactly that thing. So, like a technician, or like me, if I need to change the tires of the car of my mom, I don't need to have had the training on that special car type and tire type. I understand the concept of changing a tire, and I can work with tools that I borrowed from the neighbor, and it all works. And that's a very significant change to what we had before. The other thing that I think changes the game here for us in many ways, in the train maintenance segment especially, is everybody is talking about them, the large language models, but I don't want to mention too much the thing about, ChatGPT, and, we've all heard those stories, and it allows our kids to make their homework faster, and it saves us as parents a lot of time. So it's awesome, right? But they have some special they bring special capabilities to the table that are maybe less visible to the general consumer, if you want. One is, there's a lot of translation capability that suddenly is available. So we, especially in Europe, we have these issues with all kinds of data being in all kinds of languages, and now this can be bridged very easily. I mean, there's other components that you need for that, but it's there, right? So this is a substantial improvement if you think about it, right? You can search in Persian language in a German database, right? Imagine this. A couple of years ago, this was unthinkable, right? Then the second key thing, and it's especially important in my opinion for the exchange of data, is that it allows you, those systems allow you today, or those capabilities allow you today to extract data from documents and websites and drawings. And I will show an example in a second. And so in an automated way and in a smart way. And that's very powerful because the information about, for example, in my segment here, parts, but you think of all other things, repair instructions and so on. Usually there's a lot of information hidden in all kinds of sources, documents, and you name it, right? Reports and so on. And the problem is it's just everywhere. So a human can do this, but it's a terrible job, right? And now suddenly we have technology to automate it. We as humans have this. And the last item here is, you can, and it's very important again, those systems allow you, so large language models especially, allow you to structure unstructured data. So imagine you have data coming from all kinds of sources. I mean, this is great when you have it, but then how to really bring it into order so that you can do something, so that you can say, okay, this is the information about the weight of this part or the voltage of this switch and whatever, right? And this is something that those systems allow you to do in an automated way. And what this means is that, and it really is something that we just have available now in a working and productive way since maybe a year or a year and a half. We have a technology that means that you can access data, you can structure it, and you don't need to have, an agreement on what the structure of the data needs to be and how everybody has to provide data. Basically, you can provide the data in whatever way you have it available, and those systems make the best out of it. And that's extremely interesting because it allows you to do all kinds of things. So to give you an example here, what we do with it is, again, in the part search space, is we enrich the data that our customers have. And again, why do we do this? Because once you enrich the data, if you have more data about a part, actually, guess what? The search becomes easier, and the technician can make a right choice and all the good things. So here, what you see here is an example where the original information in the SAP system is a very basic information about a vendor and a number, and sometimes it's even less than that. And you get those, and you can't read this well, but that's kind of part of the story here, because you basically you can automatically start to look in all kinds of sources, internal documents, systems, and also the web, supplier platforms, websites, marketplaces, for additional information about this part. And those technologies allow you to basically not just gather this information and then someone says, okay, here's 200 kilograms of additional information about this part, but actually to fuse that into a good structure and make it available so that it really helps you for whatever you want to do. And so this is available. This works, right? And I can say this works because we're using it for our little case. But this is generally possible today. And what, again, the power of this is you don't need to discuss data structures so much anymore, right? You can access things from all sides. In our world, for example, what does this mean? You get better data about, you now automatically can generate better data for your parts. And this is, as I said, improving your search capability. Awesome, right? That is saving time and all the beautiful things that come with that. But what it also does is, once you have better information about parts, and all kinds of technical attributes and so on, you start to be able to identify duplicates in your environment, even if they are named differently, even if they come from different suppliers and so on. You start to understand what you have, twice, or what you're always buying from 15 sources. You even can identify alternatives, right? So what is an alternative part if my supply chain for this part is in trouble or in danger or things like that? And this is, again, so what I want to say here is that combining information like in predictive maintenance in other areas of train maintenance is actually not just making the first task here, in our case, search better. It's opening up completely new possibilities of understanding what you can do. So this is more like, if you look down here, this is more almost on the warehouse management, supply chain, procurement topics than it is for helping the maintenance technician in the field, right? But it's very powerful, of course. And so my question here to all of us, to a certain extent, and then I'm done after that, is we're building this, with our product, and we're enhancing it, and it's all beautiful, and we're bridging this gap. But in fact, the truth is that if we started to work together on this, operators, suppliers, OEMs, and so on, we would bring this to a completely different level. And this is just in my little world of parts identification, part data search, and things like that. And so what I want to finish with basically is that, in my opinion, that what we see, we truly see it with our production systems and so on. If you improve the data you provide, good data you provide to an AI system in a linear way. So basically, everybody adding a little bit of whatever he or she has, you achieve exponential improvements of the capability of this AI. So the question for everybody here from my side is, I understand we have all kinds of interests and so on, but if we look to the west of our European continent, in the US, you see large players combining everything and all the data available. If you look east, it's the same. And I think that especially in Europe, we should look at, are there ways where we can combine our knowledge about all kinds of environment, like, status information, but also on the parts information side, and actually build something that is way more powerful than what we could build alone. And that's the end of my story here. And with that, I'm back to Paulo. Yeah.
Thanks, Philip. I think we will explore a lot this topic and this question in the panel discussion. Now I have to introduce our first speaker, Nenad Mijatovic, who is Director Mobility Data Science and AI in Alstom. He has more than 20 years of experience in a different part of the technological ecosystem, I would say, including academia. And now in Alstom, leading this team, is in charge of delivering innovative digital solution, specifically also on AI. So I think he will bring direct experience on the opportunity provided by this new solution. So Nenad, the floor is yours. And there will be some polls during the presentation of Nenad as well.
Thank you so much, Paulo, and thank you, previous speakers, on a great discussion. I did enjoy it. And the first question that we would like to answer here, I guess we all echo yes. And let me try to build even a stronger case for this. So why, smart and modern maintenance? So my team right now is developing different solutions for many of the businesses within Alstom. And if you look at the maintenance part, the main goal is, can you optimize the maintenance of the train signaling systems, wayside, name it, right, rail infrastructure in a new way, right? And as Philippe from SNCF explained to us, is yes, they're using a lot of different data, right, that they're collecting from all different places. We also use a rich experience in mobility, right? We also understand what were the best practices And then with support of all these new technologies like data science, like statistical approaches, machine learning, and recently AI, right, we are able to provide, what is really wrong with the train, with asset, and then really explain to the end user, the maintainer, right, what was the problem and how that problem should be addressed. So I would like to lay over this maintenance process with something what is close to me, right? And that, as a data scientist, that is data and algorithms or models. So echo on the 2 terabytes of data coming from the trains, the answer, I definitely yes. But the first step here is, data availability. So we need to select and get the information from different data sources. So the data might be coming from the train, might be coming from the cameras, might be coming from different places. And also the big question here is, do you need your data in a real time or in a batch process, where the train, for example, in the depot, where we can dump the large amount of data when the Wi-Fi connection is available. Then Philippe from SNCF mentioned super important thing, and I love the example with the triangle which is related with the data quality and the data selection. So a lot of data are available right now from the rail systems, right? But for me as a data scientist, not all of them are important, and not all of them are equally useful for the selection of the right model. So we are spending a lot of time on cleaning and pre-processing the data, so understanding the context. But at the same time, right, we're trying to select the appropriate data sets, not only because there are so many data points, but not all of them will have the impact on a maintenance equally. Once when we understand the data points, right, then we're going into the development of the algorithm, right? So that algorithm, statistical algorithm, machine learning algorithm, deep learning, AI, name it, really doesn't matter, right? But something what is super important, and that is the new concept for the maintenance, is not only maintenance of the devices, but also maintenance of the algorithms. So once when we develop the model, once when we deploy it, right, we need to make sure that we're maintaining it, because in our industry, that is like developing any other software, making sure that you have a traceability of and also adoption of the algorithm in a new environment is super important. So this is the slide that I like because it kind of showcase that we as a data scientist, as a system, right, are getting the information from, first of all, our devices, Alstom connected the products, from a signaling, infrastructure, rolling stock, name it, right? Then from the Alstom services, so the maintenance data, the asset data, the data from the parts, for example. But at the same time, right, in order to get the full picture, as Philip mentioned, right, the context, right, it is mandatory or preferable to get the data from other. So basically, that's the bottom part of the slide, where the data are not directly available to Alstom. So we need to try to figure out how to get this information from others, such as the public transport operators, like public transport authorities, cities, etc. So basically, what you can see here from this slide is that definitely collaboration between different players, right? We really fully unlock the potential of the algorithm. And now, if I don't mind, I would like to get Jules to pull the first poll.
Yes, thank you, Nenad. Let's show the poll, please, and the screen. Yeah, provided the data is anonymized and GDPR compliant, of course. Are you happy to share your business data with others, knowing that your business will benefit at the end of in the end for your specific use cases? Almost all data, we're happy to share almost all data except confidential data. Happy to share basic data only, or no data at all. What is your take on this? Do submit. We've got quick, maybe 5 more seconds to decide. And yes, you can We're going to close in a minute. Yes, I think let's close the poll now. And I think you can see on your screen the result.
That is correct.
Fairly positive response, I think, from the audience. Nenad?
Beautiful. Thank you so much. I can see that around 16% of the people are not willing to share, and I would love to reach out to you guys and understand why. But the numbers are slowing down, so that's good too. So can we move to the slide deck, please? So we covered the data part, right? So let me talk about another topic, which is using the right technology for the problem. So within the maintenance topics, there are a lot of different things that we need to do, right? So we need to perform the prognostics. We need to, make sure that the dynamic maintenance planning is in place. So when the train should be in a depot and when should be released. We need to put the smart troubleshooting in place. So Philip mentioned that in his business they're using the new models, right, to understand the content of the parts, etc. Or there is a lot of topics related with detecting the defect of the different assets, right? As well as the most importantly is, can you really predict when the part is going to fail? And then, what you can see from this slide, for all these different topics, for all these different use cases, there is no single algorithm which will be the best for the job. Okay, and that is something what I would like you to take as the main takeaway from this slide. So, in other words, if you look at on the right hand side of my slide, where I'm talking about good old dynamic time warping, the algorithm almost 40 year old, used for aligning audio signal, right, to understand the certain words, to the autoencoders, which right now are established as one of the de facto main tools for performing the anomaly detection, as well as using all these large language model transformers that we're using for very, very specific use cases, as well as trying making sure that there is a chatting capabilities between our solutions as well as the end user. And finally, using the new tools which will embed not only the good all known deep neural networks topics, but as well as the physics, because we're working with a lot of physical phenomena with our devices. So what you can see here is based on a good old no free lunch theorem that I can use the same algorithm for all different for the different use cases, for different data sets, as well as different targeting platforms, because the same algorithm, like large language model, I cannot deploy easily on a device which is 20 years old, sitting in a locomotive, right? So we need to leverage really the right real expertise as well as the data science and AI in order to select the right tool for the job. This is an example of the solution that we developed, which is detecting the reasons, and Philippe mentioned that, right? There are very, very few in-service failures which might happen here and there. So data are super scarce, super expensive even to get, and of course it's very, very hard to test in the field. So what we wanted to do here is we want to prevent these in-service failures. So we wanted to detect in the case of the radio communication between the train and the ground is going to degrade it. Can we detect that up front, and also can we put the system on the top of it, which will allow maintainers to perform the actions even they happen, right? And that is something what we developed. It's called the radioscopy, where basically we are capable of predicting the failures and reduce the service disruption before even that happened, right? And I'm not sure if you can see on this slide, but I love this slide. It basically shows a lot of cables which are going outside and feeding the rail antenna. And with this algorithm, with this solution, right, we detected that one of the cables is is defected, right? So one of the cables is having the issues. We, reported that to the maintainer. They went and checked, and yes, in this is the real picture. But what is really cool here is, the reduction of the signal in antenna was due to the RAT, which basically add the isolation of the cable. Okay, so what I like to make the joke here is the algorithm is not going to detect that the RAT ate the cable, but it will detect that the cable was degraded, so the overall signal will be under the stress. And then, what I would like to, finish here with a couple of topics and couple of giveaways, right? As a data scientist, what is super important for me is the data. So as much possible data, great. The multimodal data coming from different sensors, perfect. But definitely, I'm not capable of getting all this information in one single place. So for us, but I believe for the whole audience here, the collaboration and insights and understanding of the data are very vital for our industry. Okay, and I have that first-hand experience. Only by improving the data set by one data point, or reducing the number of unnecessary points, right? We're capable of using the same algorithm, absolutely the same, no changes. We gain anywhere between 5 to 10% of the performance improvement, right? So responsible data sharing, fostering the strong governance, right? We can build more effective algorithms. And finally, what I would like to remind you again is there is no one-size-fits-all solution, right? So we need to still start, keep developing very custom AI for very specific use cases, and then share the experience among all. So thank you guys so much for your time.
Nenad, I believe we have one more poll from you.
There was one more poll, yes.
Let's do that quickly before we move on. So if we can show the poll, please. So this is a very similar question to the earlier one. Are you happy to share AI knowledge, so this time AI knowledge and best practices instead of data, knowing that your business will speed up development and deployment for your specific use cases and projects? Almost all data except confidential data, or basic data only, or no data. So similar to last one, but this time specifically about AI knowledge and best practices, presuming data is anonymized and GDPR compliant, of course. So the audience can, if you can vote, 10 more seconds maybe to vote, and we'll close the voting. Yeah, thank you for voting. If you can make your final decisions, and let's close the vote, please. So you can see on your screen once again, sort of, I think, similar distribution.
Yeah, Nenad, you have not convinced more than the one that were previously already on the sharing. So I hope we can use the panel to push further on this. And further sharing the advantage of this. Okay. So I think we got a free very interesting presentation from different perspective on our topic of today.
And while sorry, Paolo.
While all the speaker will come back for the panel, Jules, maybe you can launch the last poll.
Yeah, let's launch the last poll, and this will lead to the discussion. So, what are the most important enablers of AI for train maintenance? So, if you can select up to 3 answers, 1, 2, or 3 answers: availability of significant amount of data, or is it quality of the available data, overcoming confidentiality and security issues, unlocking data from various equipment, federated learning, or is it carefully designed algorithm? So if you can select up to 3, the system will allow you to select up more than 3, but do keep it to 3, which will make it more interesting.
So this will give us more elements for our discussion.
Yes. So if you can
We
make your
can
selection.
of course, the total shows us already that there is no topic that is not relevant at all. But of course, it's worth to understand about the weight of the different. The topic of data quality was highlighted, I think, by all speakers, by especially by Philippe de la Harpe, later by Nenad. It seems to be the one at the top. All the others are in a close, let's say, range of percentages.
So let me just close the poll. So if you can make your final decision, final choices, and we're going to close the poll now. Yes, let's close the poll, and the results are on the screen. Thanks.
Perfect. So maybe we can start from that. I will ask to Filip Deskovic if you can comment. Is something you expected, this kind of distribution?
I was participating in the poll, obviously, and I struggled to make the choice because all these things are relevant, and I'm not surprised that everybody, or like I would say, a lot of people chose quality of the available data, because that is, of course, well, we all know the, excuse my French here, shit in, shit out thing, right? So that's key. Yeah, if I may add, I think this. I think we heard it from the presentations of Philippe, Nenad, and it's the same on our side. On my side, this cooperation among actors to combine information, whether you call it federated learning or any other things, that's, I think, the other key thing. But yeah, that's my opinion.
Yeah, and Philippe, the other Philippe, is the kind of, let's say, ranking you expected from this poll?
Well, certainly about the quality of available data, and from what Nenad said, I hadn't much doubt about it. Overcoming the confidentiality and security issues. Well, security is something, but I think in the railways industry, we are quite used to manage this. But the real thing is not confidentiality in the sense of GDPR, but more in the sense of business value, and that's our main problem: how to share the value between the various parties. So once we have that, I have quite confidence that there are means to do the federated learning. Have to agree about who gets what from sharing, okay? And that's a big question. Once we are convinced that working on a use case, we all get something back, I think we will go for it.
Yeah. And then any additional thoughts?
Yeah, I fully agree. What is interesting here is that overcoming confidentiality and security issues, as Philippe said, right? Especially in our industry is different, right? So if we and I have to admit that this is the answer that I picked because if we overcome this, everything else was kind of nicely fall in place. So quality, definitely, we know that. Availability, absolutely. Getting the data from the various equipment, sure, right? So that's point. And federated learning, super important. I think that's, and I fully agree with others that along with picking the right algorithm for the job, right, would make us super.
Okay, thank you. So I will use then we have about half an hour to share or to ask your reaction to some of the questions coming from our audience. So there is the first one from Victor. He asked about I think a key topic, probably Nenad mentioned it also, how we can ensure that the AI-driven decision will align with operational demands and I would say operational constraints and rules about the use of the resources and so on and so forth. So Philippe de la Harpe, you are a train operator, so I will start from you in order to put your views on
Thank
that.
you, Paolo. This one is crucial indeed. In fact, luckily, we do not have too much real-time operational demands. And train systems are quite carefully designed to ensure that. And there are many high-level alarms that do not rely on AI to do that. Okay, that's the first thing I want to say, because safety is there, and safety is there to stay. And without AI, it still works. However, when we have to adapt quickly to a new situation and using AI, it has to be on, I would say, on a minimum set of scenarios. So it's not too wide. We have to wait, I would say, various opportunities, and AI decision support helps us to choose between options. But those options in operational situations, they have to be prepared because in the other case, you cannot execute them. So how we ensure that it is aligned with operational demands, it helps us to choose between options we have already prepared, and this is a decision support system. And so the answer may be quick, and the execution is already prepared. And that, in my sense, that's the opportunity.
Okay. Nenad, Alstom is also in charge of service and maintenance of a lot of the rolling stock he produces. So I think you face also this element in as part of the overall, let's say, development solution for this area. What do you think about this question?
That's correct, and I will also agree with Philippe that in terms of the operations, right, AI is still kind of in infant phase, and what I want to say here is, in order to have the AI-driven decisions in real time, you need to get the data in real time as well. So that is one of the challenges that I mentioned very briefly is, many times we receive the batch of data, right? Not the data in real time. And also the definition of the real time might be, different. So how quickly you wanna make the decision, right? An example might be if you're using the existing CCTV camera feeds to understand the number of people on a station, right? So that part is example of the real time, where we are detecting the number of people, right, currently at the station, based on which the operator can release more or basically release more trains, or maybe slow down some trains to save energy, right? So again, but many of these topics right now are still not fully AI driven, right? So the operational part is still limited in this domain.
Okay, we have a lot of questions, so I will move to the next one, and this will be first for Filip Deskovic. One of our audience members, Ruth, asked whether GPT-4 replaced the capability of computer vision with respect to AI. I'm asking whether you can provide any view on that, or other speakers.
I'll try, of course. I'm definitely not. I won't. So GPT-4 is a version, of course, but it's probably the question about large vision models and so on. How are they going to
exactly
impact computer vision? In my opinion, and again, this is me, right? But in my opinion, we, there are for some tasks, those large vision models, I think will be the future, right? So they, when it comes to things around, for example, extracting data out of image information and so on, that is very powerful. In other areas, we have to do a lot with industrial organizations who produce things, and we have it in train maintenance as well, where you have computer vision approaches to identify failures or damages. There, I would say I don't see the big benefit of those large vision models compared to other already existing technologies. So I think it's going to depend on the task you're looking at, but they certainly open up use cases that we haven't been dreaming of 2 years ago. Yeah.
Okay, try to connect a slide question that are to the same topic. There is another one about AI and telediagnostic for defect detection. If this we can help on repair side combined with virtual reality. Philip, the SENSEF is employing this combined approach.
Yeah, definitely. For inspection tasks, AI is a great helper, either from time series data from sensors that enables us to detect whether a part is wear, damaged, or has to be replaced, and also from vision systems, we are able to detect defects. The real difficult thing is not detecting defects and reducing in-service disruptions in the end. That's quite the easy part. The difficult part is assessing that everything is okay. And if we want to guarantee that inspection says everything is okay, either with the machine vision or sensor data, it's quite the same problem. It's much more complicated because you have to have some kind of safety assessment of your AI system, and that's really tricky. And up till now, it's very, very difficult, and there's not a common agreement about how it's going to be done. But anyway, for helping the crews to detect defects, to accelerate inspections, and then yes, it's really useful, but subject to human validation. And VR may be the very thing too, where, especially with the large vision models and so on, if we can combine the actual environment and the what should be from conception data or so on. It still requires, I would say, heavy computing and also heavy helmets. Not yet ready, but it's yes, it's exciting.
Okay. You mentioned the topic about safety review of AI, or there is also a question of one of the participants, Pierre. Are the models validated and verified before being deployed? Is there any AI certification involved? Nenad, what is your perspective? I think Alstom is always very focused on being quality proved and certified on everything. So
I knew that you're going to ask me this question, Paul. So, first of all, we do have the model validation and verification before it's been deployed. And that's why, the part which I have later on, and that is a maintenance of the model, is, even more important later on, because the conditions are just changing. The way how the train is handling, more people, less people, different, changes in the climate, whatever, right? So there is always, we call that data drift, that the model should be adjusted to, right? So the answer on the first question is yes. The second part, which is super important, is about AI certification, right? So there is quite a bit of in our, and again, I'm not coming from the rail industry, right? But I know enough to be dangerous. So I know that when there is a safety critical application, there is a lot of certification put in place, right? So right now we don't have the same for the AI. Okay, so the AI right now is there are no means of certifying it as we speak. However, for the last 2 years, if you guys see, one of the main trends in the AI is how to make AI safe and how we can make it explainable and, more importantly, trustworthy. Okay, so that's there is there at the end of, if you recall, some of you, EU Commission released the European Union AI Act in May, which basically talks about how the AI should be trustworthy for the usage, depending on a different criticality of your application, right, within the European Union and its member states. So this act will, as a political act at this point, right, will be in power, right, in a couple of years, and now it's up to the bodies to specify what will be the rules of the game in order to certify AI, and then there will be a specific bodies which can certify AI to be used within the European Union. Okay. So right now, as we speak, if you guys, whoever is right now on the call, that is the hottest topic for me and the team. Anything related with the trustworthy AI and make it safe and at the end, certified in the rail, for the rail industry, right, is the big stuff. There is quite a bit of again, we cannot do this alone. And even in France, there was few big collaborative bodies, right, which are thinking and building methodology, making sure that the algorithms are explainable, the data are of the good quality, etc. So everything what will consist to provide the trustworthy AI for the different industries, right? And we're talking about not only the railway but automotive, etc.
Okay, I think you cover extensively the subject. Also, to provide more answer to the many questions we have, I will move to the next one. Philip Deskovic, there are a couple that are more related to, let's say, that arrived during your presentation about technical aspects. So one is about what is the accuracy of the identification under different circumstances, like lighting and background, from Arkady.
Yeah, so I'll give a short answer because I don't want this to turn into a product demo or something. But of course, Arkady, you're referencing to all the problems that exist in the real industrial environments, right, with dirt and bad lighting and users who are not computer vision freaks, who just need to repair a train and they don't care about I would say every gray hair I have comes from thinking about one of those issues, but it's not a problem anymore. So the results are very good. I mean, you always have this last item and that never works, but the precision is very high and very independent from backgrounds, also with interestingly broken parts and things like that. So where they don't look anymore like they looked before. That's the advantage of this whole, what I mentioned in my slides, the semantic thing, right? So the understanding of something, and then so it's massive, the improvements that were made by I would say the community, scientific and software industry in that space. Yeah.
Okay, thanks. I will come back now to the main topic of the discussion, which is collaboration, because there are 2-3 questions about that. So the first one I will put on the discussion is the one from Clement. What do you think are the levers of collaboration to make it possible? to have trustable, complex model for safety use cases. So it's the number of adjectives means that the complexity is very, very high. Philippe de la Harpe, I will ask you to start trying to answer.
Yeah. First thing first is that, well, for safety use cases, collaboration, in fact, is mandatory. We do not have, luckily enough, safety issues to do machine learning on them. So we have to share on these issues, and everything that is safety related is not a matter of competition. It is a matter of safety, and thus it is a sectoral approach. And I think it is already in the past being the case that on safety, operators and OEMs and equipment builders, that they are already cooperating. So that I would say on safety use cases, that's the first thing. The second is that we have a huge work to do in common in research bodies or standardization bodies to define what is the safety case, what is the extent of the universe that is going to be explored by the AI system, the ODD, operational design domain and operational domain in general. Either the more complex being the vision system for autonomous trains, okay, but also for other systems, we have to agree on what are all the possible variables, what are the boundaries, how we ensure that we do not go behind that, and how is this universe, I would say, continuous from a data point of view, from a mathematical point of view, is sufficiently regular so that we can prove something. And on that point, so there has to be an experts agreement. Linked with the work from the AI specialists. We have to bring our sectoral specificities and see how it fits with the AI approaches and how we can use one or the other to prove that this specific area under those specific conditions is trustable within some limits, and with the help of other non-AI safety systems. I think that's the approach, and in any way, at TC9X from CENELEC, there's, I would say, a survey group that tries to identify the topics that would be touched in the railways area, and that links with JTC21, which is working on all the AI standards in application of the AI Act. So it's still, like Nenad said, an open and very, very hot topic.
Yeah, nevertheless, I do think here the focus is not just to have trustable models, but to let's say, trigger collaboration, and so not SNCF owned model or Alstom one or Partion one that are trustable by his employees and his management, but also across the industry. No,
yes.
So Nenad, what do you think? Are you discussing with other OEMs from Hitachi or CAF or about this kind of topics, how to create a higher level of collaboration about this?
Yeah, we do discuss using this kind of exchange, or as I mentioned before, right? Especially in the case of the trustworthy AI, we are part of the similar collaborative groups. Philippe mentioned one thing which is important. Whatever he said, I fully agree, right? But I have a comment here where the command asks, how to make trustable complex models, right? Whereas basically the model is more complex, it is less trustable, and making sure that you explain a complex model is one of the hot areas right now as we speak. Okay, so that's something what I would like to add here as additional comment.
Okay.
Philippe mentioned everything very well for the safety use cases, and right now AI is kind of banded for in a safety use cases, and the reason is very simple. We don't know how to make it fail safe, or how to deterministically act in a case of uncertainty, right? So when you look at the safety applications, you're starting from the requirements, right? So if your requirements are covered, your safety use case is covered, right? In our case, we have the data, very uncertain. We have the model. Okay, you can make the model to be certain in certain cases, right? But again, data-driven part, it will make our job very, very challenging, and I believe that we get it right at some point in time.
Okay, we have the time is running very, very fast, and the topic is super interesting. But maybe on this question, Filip Deskovic, you would like to add something else on what was shared before I move it to the next one?
No, not too much. I mean, we're, I think with Philippe and Nenad, we have much more expertise on safety use cases and so on that I can provide. When I think about levers of collaboration, I think one is, and it was mentioned 200 times today already, is the data piece. So I think that this is the first step that you can actually, even if you build it for your own, but everybody benefits from everybody's knowledge, basically. And then, yes, I think if you, for all kinds of use cases, if you can build a cross-organizational model, that is the second layer, and that for me, those are the two steps we need to tackle. But I would start with the data. Yeah.
Okay. There is another more focused and long question. I'll try to summarize. Acknowledge that the new trains are equipped with a large number of sensors. This question is from Ove Skovdal. But only the train manufacturer knows how much is collected, and in principle is the owner of the data. Train operator and infra manager may buy this information, but only if they know what they need and what is collected. Who has the overall responsibility? So who would like to start on this complex one? Filip Deskovic, I will ask you why the other two, they are more involved directly.
Yeah. Well, that's funny, because that one is precisely a comment I had in private with the presenters. That's all the object of Data Act legislation, which, by the way, has been published just the beginning of this year. It's the question about how to share the data and who's enabled to build value on the data. So one of the answers to this question is given by the Data Act. It says that, the user of the train considers that as a connected object also has a right to access the data and to interpret it, and to let other third parties build something on it for its I would say lawful purposes. And it is really something important that will push us all, because all the operators have obligations in this sense, to share data and to rethink our positions to how we build value. In my opinion, this time where we were all sitting on our data dams, where our data reservoirs belonging to us and nobody else, it is not gone, but it is to be considered as something from the past, and we have to think about how we add value by knowledge, by trust, and by good engineering. And maybe that's something answering to this question. Well,
Okay.
we all get a push in the back from the Data Act, and we will be forced in a way or another to share this data coming from the train, yes, but also produced from the operators, produced from the users, and this is something that has to be shared among the value chain.
Nenad, your reaction before giving to Philip the last word on this?
Yeah, I absolutely agree. So, it is very, who owns the data, right? Which boils down to the, can we share or not, right? So at the end, if I own, right, and I have the bigger benefit of sharing because I can get the data, which are, I will always have as an individual player, I will always, have one single subset of the data. So if I can, enrich that set on more, right, meaning that I can share my own data, I will benefit. We all benefit, right? So it's really, I understand the question, and coming into this industry, this question was always very. I mean, it's a legitimate question, but at the end, we and Philippe said that, right? We're collecting terabytes of data, but really, what is important here, right? So do you want to share terabyte, or want to share only this few points, which are
Exactly.
making the stuff to fail in a tragic way, right? So
your point about data selection that was mentioned before. We are approaching the end, so I asked Philip Deskovic also his final views on the discussion about collaboration we had today, and then I will make some final remarks.
Okay, I'll make it super short, Paolo, so that we stick to the time. To this year, my personal opinion is, we are, and Philippe mentioned it, we are coming out of a time of extreme protectionism, right? Active and passive, so it just happened, right? But nobody shared. I think when we look at history, when we look at other sectors and so on, eventually protectionist strategies do not work out, and once they are broken up, new things come that are so much better than the old world, that I would say this is what we need to get our head, as an industry, we need to get our head around sharing it, and not asking for money for every little piece of information, but actually trying to figure out how can my customers or my suppliers benefit from what I have, and we together build something better. That's my opinion.
Thanks a lot. Thanks a lot to all the speakers and participants for today's discussion. Unfortunately, few questions we are not been able to answer, but Nenad is helping providing answer in the thread, so you will find some additional feedback there. I think the topic, this is not a final discussion. I think we will certainly be involved again in this topic. We try to understand, to highlight the benefit of sharing in order to improve the quality of algorithm, to also make faster their implementation, and to make more trustable by, first, I would say, manager from the railway sector that in some cases they need to be convinced about the power of it, and then also by all wide range of external stakeholders that are very, very important, including safety authority, regulatory agency, users, clients. And the benefits are there. I think they become to be very demonstrated, but probably what should be built around is a, let's say, established ecosystem, which is made by contractual arrangement. AI Act will help. Is made by regulation. Is made by also, let's say, a higher relevance of this topic, which is not pure technological, because we discussed today about maintenance planning, operational planning. So it goes well beyond the scope of work of a CTO or a CIO of railway operator, in order to create this, let's say, willingness to cooperate from all the actors. So thanks again for this very fruitful discussion, and to Partium for sponsoring it. Jules, you have the floor for the last remarks.
Thank you very much, Paolo, and thank you everyone for this very active discussion on a complex and very relevant topical theme. And I hope you all enjoyed the discussion. And if you did, and if anyone's interested in hosting a webinar with us, do get in touch with us. It's the time now, so I'll leave you to everyone to lunch. And yes, but thank you everyone, and do remember there will be an evaluation form if you stay until the end of this session. An evaluation form will pop up, so do respond to that, otherwise you'll get an email. Thank you once again to Filip Deskovic, Nenad Mijatovic, Philip Dolab, and of course Paolo Guglielminetti for the great discussion. Thank you to Partium, and I hope to see you again soon. Thank you, everyone.
Thanks a lot. Bye-bye.
Thank you. Have a good one.